Good morning, everyone. So we are going to discuss about UV visible spectroscopy and the basics about it. So UV VIS, it basically stands for ultraviolet visible spectroscopy. So it is a kind of spectroscopic technique which is used for detection of organic compounds. So the objectives which are included in this presentation. So we will first know about spectroscopy, the basics of spectroscopy, what spectroscopy stands for, what are its uses. Secondly, we will understand the basic principles of UV visible spectroscopy. So we will discuss about the basics of ultraviolet visible spectroscopy. And then we will discuss in brief the concept of electronic transitions. And in the end, we will discuss a few applications of UV visible spectroscopy. Because in order to understand what is a chromophore, it will take a little bit of time. Now, what is spectroscopy? So, the branch of science which is concerned with the investigation and measurement of spectra produced when matter interacts with or emits electromagnetic radiation. So, as you can see in this diagram, okay, so that is what is spectroscopy. Now, what are the basic principles of spectroscopy? So, the principle is based on the measurement of spectrum of a sample which contains a specific number of atoms and molecules, and the spectrum is obtained as a graph of intensity of absorbed or emitted radiation by sample versus frequency or wavelength. So we will have absorbance in one on the y-axis or on one of the axes, and we will have wavelength or frequency on the other axis. So the spectrum that we get because of this emission is basically obtained in the form of a graph which measures the absorbance versus frequency or wavelength. Now, spectrometer is the instrument which is used for the purpose of spectroscopy. It is designed to measure the spectrum of a given particular compound. Now, what are the different types of spectroscopy? So, we can have absorption spectroscopy. And what is absorption spectroscopy? It is an analytical technique which concerns with the measurement of absorption of electromagnetic radiation. So as you can see that this is what is happening. You have a cold gas, and in front of that if you keep a source of heat, so this is high density hot matter, so it will absorb the heat and it will emit a certain spectrum, and this emission is known as the absorption spectrum. Now UV that we are concerned with, that is the ultraviolet emission spectrum, it ranges from 185 to 400 nanometer, and the visible spectrum, it ranges from 400 to 800 nanometer. So the entire ultraviolet visible spectroscopy, we say that the range is from 180 to 800 nanometer. Now apart from UV spectroscopy, we will also have IR spectroscopy in the range of 0.76 to 15 micrometer. Now, after absorption spectroscopy, we have emission spectroscopy. This is the other type of spectroscopy. An analytical technique in which emission is dispersed according to some property of the emission and the amount of dispersion is measured. That is known as the emission spectroscopy. So here, this is what we are having. So we do not have a material which is cold, which is being heated to emit a spectrum. This is a material which is already hot, which has an innate or an internal source of energy, and it can emit radiations on its own. Say for example, we have any hot gas which can emit radiations, and the spectrum that we can obtain is then known as the emission spectrum. So the basic difference between the absorption and emission spectrum is, in absorption spectrum there will be a medium which will absorb the heat radiation and then they will emit the spectrum. And in emission spectrum we will have a source which is having an innate source of energy and they can emit a spectrum on its own. So example of emission spectroscopy is mass spectroscopy. Now there is a third kind of spectroscopy, and that is known as the electronic spectroscopy. So what happens in electronic spectroscopy? So it basically involves the transition of electrons within a molecule from a lower to a higher energy level or from a higher to a lower energy level by either absorption or emission of radiation, and that will fall in the UV visible range of the electromagnetic spectrum. So as you can see, there is a light source, it passes through the lens, then we have a wavelength separator. This is the sample which absorbs the light source, it gets detected, and we have an output display. These are the approximate wavelengths of these regions. So we know that these are the most common spectral region in the spectrometer or the electromagnetic spectrum. So you will have a visible that is from 4000 to 8000 angstrom unit. You have near UV 2000 to 4000, far UV ranging from 1500 to 2000 angstrom. Now, it's very important to understand the basic concept of Lambert-VIS law when we discuss about ultraviolet spectroscopy or UV spectroscopy. So here you can see that there is a source of light which is falling through a sample which is taken in a cuvette. This is a kind of a glass container or a cuvette containing a particular sample, and there is a light source of intensity I naught, and the emitted light source has an intensity of I. So the mathematical formulation of Lambert-Weiss law is log to the base 10 I naught by I is equal to epsilon L into C. Here I naught is the initial intensity of the light source that we are using, and I is the final intensity of the transmitted light. Epsilon is a source of it's a constant source basically. Then you have L, which is the path length, and C is the concentration of the sample in moles per liter. So as they're saying that I naught and I are the incident and the transmitted light that we are concerned with. L is the path length of the solution, and it is generally represented in centimeter. Then C is the concentration of the sample in moles per liter, and log to the base 10 I naught by I, it is actually known as absorbance. The epsilon, that is the constant in this equation, is known as molar absorptivity, and it has a unit of centimeter square per mole. Now this log to the base 10 I naught by I, in other words, is known as absorbance. That is the ratio of the incident and the transmitted light is known as absorbance. So this Lambert-Weiss law can be simplified and can be written as capital A is equal to epsilon into L into C. Now, when we study about the UV visible spectroscopy, it is important to understand the different types of electronic transitions that are possible in a given particular molecule. So the first we have is the sigma to sigma star transition. So if this includes all saturated compounds where the only kind of bond available is the carbon-carbon sigma bond, and the transition that can take place is from a sigma to a sigma star. So that is basically from bonding to an anti-bonding. Next we have is N to sigma star transition, where N is the non-bonding electrons. Next you have is the pi to pi star transition. Okay, so this is included in compounds having a double bond. Even in carbonyl compounds, they can have a pi to pi star transition. And the last you have is the non-bonding to pi star transition. So as we discussed, that sigma to sigma star transition, it happens in saturated hydrocarbons like alkane, which does not have any non-bonding electrons. Then N to sigma star transition, it happens in saturated hydrocarbons having non-bonding electrons. Pi to pi star transition is very common in unsaturated hydrocarbons having no non-bonding electrons, like you can have ethylene, you can have benzene. And N to pi star transition happens in unsaturated hydrocarbons having non-bonded electrons like aldehydes and ketones. Now we come to the basic nomenclature, or we can say a few definitions which are important in UV visible spectroscopy. Whenever we talk about UV spectroscopy, we talk about a chromophore and an oxochrome. So it's important to understand the difference between the two. So what is a chromophore? So chromophore are the color producing groups present in an organic compound. So these are the molecules or functional groups which can have pi or vitals, and they are called chromophore. So it can be benzene, it can be ketone, it can be an aldehyde. On the other hand, what is an oxochrome? Groups which are not chromophores themselves, but their presence can cause the increase in color intensity of the compound is called oxochromes. So themselves they cannot produce any color, but when they are present in the compound, it can produce specific color. So it is a color enhancing group. Examples are OH, Cl, NH2. Next, we have a few different types of band shifts as to how the lambda max value can shift in ultraviolet spectroscopy. So you have a bathochromic shift. What is a bathochromic shift? Where the lambda max value, it moves towards the red end or higher wavelength. It is also called the red shift. Hypsochromic shift is when the lambda max value, it moves towards the left hand side or towards the lower wavelength side, and it is known as the blue shift. Then we can have hyperchromic shift. So hyperchromic shift is related to the increase in intensity of the absorption. So we can have epsilon max, and we can have a hypochromic shift which is related to the decrease in the intensity of absorption. So that is going to be epsilon max. So one is related with increase in lambda max, that is the bathochromic shift. Hypsochromic shift is related with the decrease in lambda max. Hyperchromic shift, it deals with the increase in the intensity, and hypochromic shift deals with the decrease in the intensity. So now about a few applications of ultraviolet spectroscopy. So it helps in the detection of conjugation, unsaturation in organic compounds. So in an organic compound, if you have a double bond or a triple bond, or if you have a carbonyl group or any kind of conjugation, that can be very easily detected by UV spectroscopy. So it is also used for the detection of a few functional groups and in distinction between the conjugated and non-conjugated compounds. Obviously, if you have a compound which is conjugated and one compound which is non-conjugated, with the help of the spectrum obtained from UV, you can detect or you can distinguish between the two. So in nutshell, we can say that it is a very important analytical tool which is used for the detection or elucidation of the structure of organic compounds. And it is also used for differentiating between trans and cis. So geometrical isomers can also be detected on the basis of. So these are some of the image sources. These are the sources from which I've obtained the images. And there are a few practice questions like discussing about spectroscopy, what are the basic terms like chromophores and oxochromes, then about the shifts, what's the bathochromic shift, what is a hypsochromic shift, what is hyperchromic shift, what is hypochromic shift. Okay, so all these things uh, are important questions which are related to the basics of UV spectroscopy, and these are the references which I have used for making this presentation. And I hope that this gives a basic understanding of the visible spectroscopy, the basics of it. That's all for